Good morning. Welcome to another math video. I'm Mr. Weidmann, as I hope you know. And today's topic is volume. We've done area, we've done surface area, and now we're going to do volume. And today we're going to talk about the volume of prisms. Here's the formula that we're going to use. You're going to want to write this one down. This formula is the formula that we're going to use for all of the volume problems that we're going to do. And it is a V equals B, and that is capital B, that's important, times H. V obviously stands for the volume of whatever shape we're talking about. The big B, I sometimes say big B, capital B, big B is the area of the base. So it's not just the length of a base, it's the big B is the area of the base, and we'll talk more about that. And H is the height. The height is also known as the distance between the two bases. Okay, so let's look at some of the shapes that we're going to discuss today. We've got these shapes right here. So in any of these shapes, identifying the base is the really, really important thing. It doesn't matter which shape is on the bottom. A lot of people think because the shape is on the bottom, that's going to be my base. It's not, okay? The base is the shape that is, the way I like to describe it is on both sides of the object. So on this one here, we've got, no matter how we turn it, we've got this shape right here. It's a hexagon. 1, 2, 3, 4, 5, 6. Hexagon here and a hexagon on the bottom. So we've got a hexagon on top, hexagon on the bottom, and that right there is the shape of the base. So if I want to find the area of this one, I'd find the area of that hexagon and multiply it by the height, which is the distance between the two hexagons. Okay. In this one right here, we've got the area of the base, and the base in this one is going to be the pentagon. Okay, because we've got the pentagon on the top and the pentagon on the bottom. It doesn't matter if it's on the top or bottom or on the sides. Okay, it's that main shape. It's on both. Okay, here we've got what we call a trapezoid, and I can show you the base here is going to be that shape right there, and I've got another trapezoid on the other side, and they're parallel to each other. A lot of times that's an important aspect of it. Okay, that's one way to decide. So they're parallel. So this right here is going to be the area of the base. Okay, we go base 1 plus base 2 of this trapezoid, multiply it by the height, divide by 2, and that's the area of this trapezoid. And then we're going to multiply it by the height, which is the distance between the two bases. Remember, we're talking about the height of the prism, not the height of the trapezoid. This is the trapezoid, right? But the H that we're talking about, this H right here, is the distance between the bases. It's the height of the prism. Okay, this right here is not the height of the prism from here to here. Okay, the height of the prism is the distance between these two bases. Okay, we've got another one here. This is what we call a rectangular prism. And for rectangular prisms, we actually, any of these sides are able to be the bases. So it really doesn't matter. But you get to pick one of these rectangles. And we can pick, I like to pick that one right there. That's the rectangle that's going to be our base. So we find the area of this and then multiply it by the height, which is the distance between these two bases, which would be this distance from here to here. We've got this triangular prism. There's my base. It's the triangle. We've got another triangle on this side, and the distance between those two bases is the height. And then we have what we call it's not called a circular prism, but that's what it is. It is actually called a cylinder. And the base here is going to be this circle. So we find the area of this circle, multiply it by the height of that cylinder. Okay, that's how we find the volume. Let's do a couple of examples. I'll give you time to write some of this down. Pause it if you need it. We are going to start off with this. Here's our triangular prism. And I'm going to go ahead and find the base. And in this case, the base is going to be that triangle right there. We've got another triangle on this side. So here is our volume. Volume equals big B times H. So we're going to go volume is equal to Now we're going to figure out what that big B is. We're going to figure out what the H is, okay? And we're going to multiply those two together, okay? So big B is equal to the area of this triangle. Well, the area of a triangle is the base of that triangle, which is 5. Base times the height of that triangle, which is 6. And then I have to divide that by 2. And in this case, 5 times 6 is 30 divided by 2. That means the big B, or the area of that base, is 15. And now I have to take that and I have to multiply it by the height. And that's the distance between these two bases, which is 12. Your job is to then multiply 15 times 12. You're going to do this on your own, no calculators, not today anyways. So go ahead and do 15 times 12, and that right there is going to end up being your volume. You want to do it? Okay, we'll do it. Okay, there's 10, 1, 3, we got to go down, 5, 1, add it up. That looks like 180. Okay, now one important aspect of this, you have to have inches. But this is inches cubed, and the way that I remember that, that should be a cube. Let's fix that. The way I remember that is it's 3 dimensions, and if it's 3 dimensions, there we have a 3 up here, or we have a cubed. Okay. All right, here's the volume here. Let's go ahead and we could actually choose any of these as our base. Let's go ahead and choose, I always like to choose that one right there, but you could actually choose the top if you wanted to. You could actually choose the sides if you wanted to, but we're not going to do that. We're going to do this right here. So our volume for this is going to be big B times H. Okay, so let's figure out what big B is. Okay, and in this case, it's the area of this base. Area of the base is a rectangle, 8 by 3. So big B is going to be 24. I'm going to times that by the height. And the height of this prism is the distance between these two bases. And it's going to be 9. So in this case, what we really ended up doing for the volume of a rectangular prism, it's just length times width times height. Because if I would have chosen this 9, this side right over here as this side right here as the base, I would have done 9 times 3 and then times it by 8, which would be the height. And you're going to get the same answer either way. So for a rectangular prism, if you want to kind of write this down, I don't like giving a bunch of formulas. For a rectangular prism, it's just length times width times height. So let's go ahead and finish this off. We've got 24 times 9. That's going to give me 36. 18, that's 21. It looks like the volume of this is going to be 216. And this is centimeters, and it is cubed. There you are. Let's try another one. We're going to do about 4 different examples here. All right, write this one down. We've got, this is what we call a trapezoidal, fun to say, prism. Our base is the shape that is on both sides of the figure, and it's parallel. And so our base is going to be that right there. It's going to be the trapezoid. So when we do our volume equals big B times H. I got to figure out the big B. I got to figure out the H. Well, big B is going to be the area of the trapezoid, which is base 1 plus base 2. We're going to multiply it by the height, and then we're going to divide the whole thing by 2. Okay, so you have to remember that area of a trapezoid. So it's going to be base 1 plus base 2. Base 1 is 4 plus base 2, which is 6. We're going to multiply that by the height. The height of the trapezoid is 6. And then we're going to divide that by 2. If you do all of that, I get 4 plus 6 is 10. 10 times 6 is 60, divide that by 2, and that looks like it's going to be 30. Now I have to do 30 times the height of this trapezoid. Remember, this is not the height of the figure, of the trapezoidal prism. It's the height of just that base, right? I want the height of the whole thing, which means from this base to the other base, right? If I took that and I flipped it, right, this would be 7. So we're going to put 7 right here. And my overall volume, you should be able to do that when you're in your head. That's 210, and it's going to be feet cubed. Whoops. That is my area, or my volume. Okay, we're going to do, I think we've got one more. Let's see what we got. Perfect. This is a cylinder, also known as a circular prism. It's really never called a circular prism, but that's really what it is. Okay, so what's my base? Well, the base is the shape that's on the top and the bottom. This one's easy. Figure out the base. It's that circle. So we're going to do our volume is equal to big B times h. I got to figure out what the area of the base is. Now, the shape of the base is a circle. So big B is the area of that circle, which is pi times r squared. Okay. Remember, this is the radius. You are allowed to use a calculator on this, so I'm going to pull out my calculator here. And we're allowed to use calculators because we include 3.14 and pi and all that stuff. So anytime there's a circle, I'll let you use a calculator. The radius is halfway through the circle. This 20 is all the way through the circle. So this is going to be 10 squared times 3.14. The good news is we actually don't need a calculator for this one. Why? Because 10 squared is 100, and 100 times 3.14 comes out to be 314. So this is the area of the base. So I'm going to come back up here. I'm going to plug this in. Area of the base is going to be 314 times the height of the base, which is going to be, the height of the prism, which is going to be 30. Actually, this yellow line shows the height of that cylinder. And now all you have to do is 314 times 30, and that will tell you 314 times 30. I did this one on my calculator, and this is going to be 9,420. And it is millimeters cubed. I hope that helps with all of our volume formulas. All you have to do today is watch the video. Tomorrow you'll get an assignment. Hopefully that helps. I will talk to you guys later. All right. Our topic today is going to be rational and irrational numbers. So you're going to want to pause this. You want to write this stuff down because you're going to need these notes. When we're talking about a rational number, we're talking about any number that can be written as the ratio of two numbers. So some examples of that. Okay. First of all, when we say ratio, when we use this this word right there. Okay. Another thing that we could be saying is that this is kind of a fraction. Okay, and I know there's some math teachers that would disagree that there's a difference between a ratio and a fraction. However, it's okay. For our purposes, okay, think of this as being a fraction. So any number that can be written as a fraction is going to be a rational number. By the way, you see the word ratio in rational. It's right there. So let's go with some examples because it's easiest to define the category of rational numbers using our examples. So first of all, we've got positive numbers, 5, 6, 7, 12, 18, 75. Those are all rational numbers because I can always write those as a ratio because I can always put those over 1. Okay, so that would work. We also have their opposites. So we have numbers like -7 because I can always say -7 over 1. So that would be -22, -38. Okay, all of those. Okay, well, we also have, of course, we have all of our fractions that we've got. So we've got fractions like 1/3, I've got fractions like -2/5. Those are all written as ratios because ratios are fractions. So we're talking about whole numbers. We're talking about their opposites. So we're talking about integers, fractions, okay, positive and negative fractions. And then we've got decimals. So we've got decimals that look something like this, 2.3. We've got their opposites, okay? We also have repeating decimals, okay? Because repeating decimals, so an example of this would be 6 and, oops, sorry, I wrote a fraction there, 6.3 repeating, because that's the same as saying 6 and 1/3, because 1/3 right here is that 0.3 repeating, okay? So this seems like a huge chunk of numbers, positive, negative, whole numbers, positive, negative fractions. We've got decimals, but do we have all decimals? Can all decimals be written as a ratio or as a fraction? Not necessarily, because if those decimals never stop and never repeat. Now we're talking about irrational numbers. So when we talk about this group of irrational numbers, it seems like it is a smaller group, but it's really not. There's just as many numbers in that group as well. It is anything that can not be written as a ratio and is a number that never stops and never repeats. So one thing we always talk about is this number pi, because that is equal to 3.14159 and keeps going and going, never stops and never repeats. Therefore, we can't necessarily write it as a ratio. So that is an irrational number. That's probably the most famous irrational number. But the easiest way to find an irrational number is to do this. To take this thing that we call a square root, okay, and find a number that it's not a perfect square. So when we look for a square root, let me explain this to you. When we look for a square root, we're looking for one number that goes into that number, okay, or that can be multiplied by itself to equal that number. So for example, I know I didn't explain that very well, okay, the square root of 16, we're looking for one number times itself to equal 16, and in that case, that's going to be 4, okay? That is what we call a perfect square, because you can take the square root of it and you get a whole number, okay? Another example of a perfect square would be something like 36, because the square root of 36 is 6, okay? These are all perfect squares, and these belong into the rational numbers category. It is not an irrational number because it comes out to be a whole number, which we know is rational, okay? So what would be an irrational number? What would be an irrational number is any number that is not a perfect square, that doesn't come out to be a whole number. So for example, the square root of, let's say, 17. Do you know one number times itself to equal 17? I don't know what it is either. It's going to be 4 point something. That's an irrational number. I can take 27. I don't know one number times itself to equal 27, so that's going to be an irrational number, okay? Because it's going to never stop. If you plug this into a calculator, you'd get a number that's going to be a decimal. The calculator would then have to round it, okay? So that's the easiest way to find an irrational number. It's a square root of something that we don't know the answer to, okay? So let's go ahead and discuss these perfect squares. What are the perfect squares? The numbers that if you put into the square root, it gives you a perfect number. Well, we start this off and we just do this. 1 times 1 equals 1. 1 is a perfect square. 2 times 2 equals 4. 4 is a perfect square because if I took the square root of 4, what number times itself equals 4? Well, that would be 2, right? We could go 3 times 3. That gives me the perfect square of 9. And we can do 4 times 4. And we can keep going with this pattern to find all of our perfect squares. The square root of 16, one number times itself equals 16. That's going to be 4 right here. You can see it always comes back to these numbers that we're multiplying. So what's my next one? The next one would be 25. That's 5 times 5. 6 times 6. Next one's going to be 36. and then 7 times 7, and 8 times 8, and 9 times 9, and 10 times 10. So those are ones that we should automatically know. We should also know 11 times 11 and 12 times 12. Okay, there are some really cool ones that we should probably know eventually. 13 times 13, we've got right there. And then some other ones like 20 times 20. Actually, 15 times 15 is a good one, 225. 20 times 20 is 400. And then things like 25 times 25 is 625. Okay, now you don't have to necessarily remember those, but these are all of our groups of perfect squares. So what that means is if I take the square root of those, I'm going to get a whole number, which would then be rational. If I take the square root of a number that is not on this list, 1, 4, 9, 16, 25, if I take the square root of that, it's not going to be a whole number. It's going to be a decimal, and that decimal is never going to stop, never going to repeat, and therefore it's going to be irrational. Okay? All right. So when we take the square roots of these numbers, we get whole numbers. Okay? So the last thing we're going to do is we're going to estimate square root answers. Okay? So on your homework, you're going to have to describe, is the number rational or irrational? Okay? And you're just going to put an R or an H next to it. An R or an I next to it. It's just going to look like this. Okay? And then the last part is going to be estimating answers. The square root of 10. What number times itself is equal to 10? A lot of people think that you just divide by 2. That is not it, okay? Because if you divide by 2, you get 5. 5 times 5 is not 10. 5 times 5 is 25. So what number times itself equals 10? Well, it's not 2 times 2, that's 4. It's not 3 times 3, that's 9. It's not 4 times 4, that's 16. So it's got to be somewhere in between those. So here's how we're going to estimate this. Okay, what we're going to do is we're going to look at our list of perfect squares. Okay, and we're going to find the perfect square that is above 10 and below 10. Okay, so we're going to look at our list right here. Okay, and I'm going to find 1, 4, 9. Okay, we're going to look for the perfect square that is above 10. And I'm looking and I see this right here, 16. And the one that's below 10 is 9. So that's what I'm going to use. I'm going to use those two numbers, and I'm going to take the one that's below square root of 9 and the one that's above the square root of 16. And what we're going to be able to do now is use these numbers to estimate. I know what this answer is. That answer is 3, because the square root of 9 is 3. 3 times 3 is 9. And I know the square root of 16, because 4 times 4 is 16. So that tells me that the square root of 10 has to be somewhere in between these two answers. So it has to be somewhere in between 3 and 4. Well, then we ask ourselves, is it closer to 3 or is it closer to 4? Well, the square root of 10 is definitely closer to 9 than to the square root of 9 than it is to the square root of 16. So I know that this answer is going to be closer to this. If it were right in the middle of these two numbers, then we'd say our answer would be right about 3.5. But because it's closer to the square root of 9, I'm going to say my answer is going to go closer to 3 than it is to 4. So now this is an estimate, right? So you don't have to give me an exact number. You can give me an estimate. I think it's really close to the square root of 9. So I'm going to say something like 3.2. And that's it. That's all you have to do. Is it exact? No. But is it an approximate answer? Sure it is. And I'm going to show you. We'll see. Hopefully you can see this. We're going to go ahead and we're going to take my calculator. And I'm going to show you what the actual answer is. We're going to take 10. And I am going to square root 10. And that's going to give me 3.16. 3.16 rounds to about 3.2. So I know my answer was pretty good. It's an estimate. It doesn't have to be exact. Okay. And today on your homework, you don't have to be exact either. All right. Let's try this one. The square root of 44. So what we're going to do is we're going to go to our list of perfect squares. List of perfect squares. We're going to find the one that's above 44, the one that's below 44. And I'm looking right here, and I'm thinking it's these two numbers, 36 and 49. Those are the ones that are right in between. So we're going to go to this square root of 44. And I'm going to take the square root of the one below, which is 36, and the square root of this one, which is 49. And I know what these answers are. The square root of 49, one number times itself to equal 49, and that number is going to be 7. The square root of 36 is going to be 6. So that tells me that the square root of 44 is going to be in between 6 and 7. And your job is to find out, is it closer to one or closer to the other? So what I like to do is I like to see how many away it is from each one of these. And I know that it is going to be 8 away from this one, 8 numbers away from the square root of 36. And it looks like it's only 5 numbers away from this. 44 plus 5 is equal to 49. So that tells me that the square root of 44 is closer to the square root of 49. So my answer is going to be closer to 7 than it is to 6. If it were right in the middle, it would be 6.5. Because it's closer to that, I'm going to take a guess. Your guess can be anything that's closer, so on the upper end of 6.5. So I'm going to say this is going to be, let's say 6.7. You could say 6.6. You could say 6.8 even. I want it somewhere close to that. And that's going to be my estimate right there. Okay. There's going to be multiple answers for this. Okay. And we're going to try one more. We're not going to look at my list right now. We are just going to do this on our own. Okay. So we're going to choose the perfect square from our list that is on this side, on the upper end of 77 and on the lower end of 77. Well, I know that 9 times 9 is 81. So that's going to be that. And that means that 8 times 8 is going to be 64. I know what my answers are for those ones. The square root of that is 9. And the square root of this one is 8. So I know that the square root of 77 has to be somewhere in between those two numbers. I am going to be 13 numbers away from that. And it looks like I'm only 4 numbers away from that. So I'm really close to this square root of 81. That means my answer or my estimate is going to be really close to 9. So choose a decimal that's really close to 9. Like you could choose 8.8, 8.9. Either one of those would work. I'm going to choose 8.8. But remember, it's an estimate, so your answer does not have to be exact. Okay? All right, that's how we estimate square roots. Hopefully all of this makes sense to you. And if you have any questions, let me know. All right, our topic for today is going to be the Pythagorean Theorem. Man, I wish I had you in class right now because I would so be able to show you where this is a super useful thing. I'm going to try my best. But this might be one of those things that is the most useful mathematical theorem maybe ever. I mean, if people are just using this all over the place. The Pythagorean theorem is such an important theorem to know how to use, to be able to understand and figure this out. Lots and lots of professions use the Pythagorean theorem. A lot of builders and contractors are using this all the time because the Pythagorean theorem deals only with right triangles, okay? And so in order for it to be a right triangle, it's a triangle that has a right angle down here, which is a 90-degree angle, right? That's super important, right? Because if it's a 90-degree angle, then they call that square. It's not a square, it's square, which means 90-degree angle, which means it's straight up and down. So you can see how this is important for somebody when they're building a wall to make sure that it's straight up and down and not slanted one side or the other. They need to make sure that that's the Pythagorean theorem, right? If they want to make something a doorway, right? It has to be square, otherwise the door's not gonna shut. So anywhere that you see a right angle or a 90-degree angle, the Pythagorean theorem could be used to help prove that it's a right angle, or it could have been used to help create that right angle. But the theorem that you have to write down right now is this right here. It is a squared plus b squared equals c squared. You're going to need to know this, okay? A, B, and C are specific pieces of our right triangle, okay? So it says that A and B are the legs, okay? The legs are the two sides that create this right angle, okay? It's those two sides. And then we have this other thing, the C value, and the C value is the hypotenuse, and the hypotenuse, we'll go ahead and make that a different color. The C value is the hypotenuse, okay? Whoa, sorry about that. And the hypotenuse is always going to be the side that is opposite the right angle, okay? And it's always, you might want to write this down, the longest side. It is always going to be the longest side. The hypotenuse cannot be the shorter side. So what I'm going to teach you to do right now is to solve using the Pythagorean theorem for a missing side of this triangle, okay? So they give me the hypotenuse and a leg, and I have to solve for the other leg, or they give me both the legs, and I have to find the hypotenuse, okay? Those are the problems that we're gonna solve right now. So let's go ahead and take this one right here, and I'm gonna switch over to the pen, and we're going to solve for this, okay? What I like to do is I like to write down the information that they give us, okay? We've got A, B, and C. Now, there are a lot of kids that do not like to take this step because that took me so long. Do it, because it's going to help us figure out what we're missing, okay? If you remember, A and B are the legs. So it doesn't matter if 7, which is one of the legs, because it forms the right angle. Doesn't matter if 7 is A or B, okay? It can be either one of those. It's just one of the legs. So I'm going to make this 7, and the other leg is going to be B, which is, in this case, is going to be 24, which means I'm solving for C, or what we call the hypotenuse. So I'm trying to find out what the length of that side is, and we're going to call that C. So now this simply becomes what I like to call a plug and chug problem. So I've got A squared plus B squared equals C squared. And because I've already written my A, B, and C up here, it's simple to just take these numbers and plug them into the formulas down here. If you don't do this, then you're going to start guessing, and you're just going to randomly put things where you think they belong, and they have to go in specific spots. A and B have to go here. You can't just float it and put it over into the C area, okay? So what I'm going to do is I'm going to do this, and I'm going to say 7 squared plus B squared, and B is 24. So all I'm doing is I'm just plugging these in, is equal to C squared right there. And now I just have to solve. This is 49 because 7 times 7 is 49. Remember, that is not 7 times 2. It's 7 squared, which is 7 times 7, plus 24 times 24. You might have to do that on a calculator. If you want to do that on a calculator, I thought I had my calculator pulled up here. I will pull it up, and I am allowing you to use calculators for this. Okay, so we're going to do 24 times 24, or 24 squared. I can hit the squared button right there. That's going to give me 576. Okay, we're going to keep this calculator, okay, handy. That's 576, and that's going to be equal to C squared, which means C squared is equal to the addition of these two numbers. So we can go back to my calculator here, and I can say 576. And I'm going to add 49, and that's going to give me 625. So if we think about this, there is no way that the hypotenuse in this problem, if this is 7 inches and this is 24 inches, there is no way that this is 625 inches. That doesn't even make sense. It doesn't match my drawing. It doesn't match my scenario. So what have I done? Oh, that's not C equals 625, that's C squared. So what we have to do is we have to now figure out how to undo this squared. In other words, what's the opposite of squaring something? And the opposite of squaring something is square rooting something. And remember, if we do it to one side, we can do it to the other side. So if I square root something, I'm looking for one number times itself to equal that number under the radical or under the square root. So what number times itself equals c squared? Well, that's just c. C times c equals c squared. So the square root of c squared is c. This and this will cancel each other off. Okay, and now I've got 625. The square root of 625, one number times itself to equal 625. Now, if you need to, this is where you can use a calculator. You punch in 625, and I'm going to hit the second button on this one, and I get the square root button right there. And I can hit the square root, and I know my answer is going to be 25. So now, before I box that in, and I already boxed it in, and match it up, I have to make sure the hypotenuse is the longer side. Is it the longest side? Yes. If it comes out to be not the longest side, you did something wrong. Fix it. All right, that's the first example problem. Let's move on to the second one. That's going to be all the way down here. And what I'm going to do is get rid of that. And now we're going to match this up. Okay, so we're going to go and we're going to start by finding, I'm looking for this missing side over here. Okay, and we're going to start by writing A equals, B equals, and C equals. Okay, so remember A and B are the legs. Those are the sides that form the right triangle. So if I want to do this color-coded, I can go here and here, and the C value is going to be the longest side. That's usually the slanted side often, but not always. Okay, that's the C value. Okay, so I can tell right now the C value, they've already given me that, that's 15. In the last one, they didn't give me the C value, but this one they did. So they can give you different things. And now they've given me one of the legs, and I have to find the other leg. So let's go ahead and say that the leg that they gave me, let's just make that one 12. And this one is the unknown. The A value is the unknown. So we're going to label this one as A. Okay, and now I'm going to take my equation. A squared plus B squared equals C squared. And because I've labeled everything up here, I can go ahead and just plug and chug. I'm going to plug the C value in for the C, and that's going to be, sorry, technical difficulties. There we go. Okay, so I'm going to plug in this. It's going to be 15 squared is equal to 12 squared plus A squared. Here is the absolute biggest mistake that I see people making. They take the two numbers that they give us, okay, and they always plug them in for A and B. Regardless, they just take, oh, they give me two numbers, plug them in for A and B. No, the two numbers have to go in the right spots, right? So if they give you A and B, then plug it in for A and B. If they give you B and C, then you have to plug it in for B and C. You can't always plug them into the same spots. So we have to make sure that we identify what those numbers mean. Let's go ahead and simplify. If you need to do this on a calculator or on the separate sheet of paper, that's fine. 15 times 15, it's not 15 times 2. 15 times 15 is 225. 12 times 12 is 144 plus A squared. And what I have to do now is I have to solve this equation. So I have to get A squared all by itself, which means I'm going to be taking away 144 from both sides. If you'd like to draw that fence, because that's the way we like to do these problems, split up our sides. I know that the A squared is coming down here. So I know A squared is going to be equal to 225 minus 44 or 144, and that looks like it's going to be 81. So the last thing I have to do, obviously, A cannot equal 81, because if I go back up here, A can't equal 81, right? It's not even close to being the right size, right? And 15 has to be the biggest number because it's the hypotenuse. So we know we're looking for a number that is going to be less than 15. So we have to come back here and we have to figure out what I did. Did I do something wrong? I didn't solve for A, I solved for A squared. This is A squared. So what we have to do is we have to do that last step, which is to get rid of a squared. And to get rid of a squared, we take the square root. It's the opposite. It's like, what's the opposite of multiplication? Division. What's the opposite of addition? Subtraction. What's the opposite of squaring something? Square rooting something. So my answer down here is going to be A, and the square root of 81 is going to be 9. 9 times 9 is 81. And let's go and see if that matches up with what I've got. It's definitely less than 15. I think that works. By the way, what they might call these, okay, 9, 12, and 15, they call these Pythagorean triples. These are three numbers that a squared plus b squared equals c squared that work in the Pythagorean theorem. So any three numbers that work in the Pythagorean theorem, they call the Pythagorean triples, okay? Here's what I want you guys to do. You can pause this video, and I would like you to do these two problems right here. Okay, so pause the video and do these two problems, and I'll come back and I'll show you what these answers are. Ready? And pause. And we're back. Okay, here are your answers for these two problems. Let's see how we did. Answers for 4 and 5. There you go. The hypotenuse here is going to be 50 feet, and this missing leg over here is going to be 9 inches. Hopefully that helps you. If you need any other help, let me know. I am out of here. See you guys later. Hello again. Let's get started on our topic. Hopefully you are good. Our topic for today is going to be combining binomial radical expressions. And so the main thing that we're going to focus on today is this property right here, which is talking about like radicals. So that just like we have like terms, like x and x, or y and y, or 2x squared and 2x squared, whatever it is, we have like radicals. And for something to be a like radical, meaning that we can put them together, we need to have the same index, okay, and the same number under the radical or the radicand. So we have to have the same number on the outside here, okay, and the same number on the inside. And if we do that, then we can just keep those things the same and add the numbers that we have on the outside, okay? Or we could subtract them, okay? Now this is only adding and subtracting, and you can see down here why this works. They prove that it doesn't work if you don't have like numbers underneath, or like radicands, okay? Because the square root of 2 and the square root of 3 does not equal the square root of 5, which is 2.23. These come out to be like 3.14. So that does not work. So they have to have same number underneath the radicand, or same number underneath the radical, and the same index, or the same either the square root or the cube root, something like that, fifth root, whatever it is. Okay, so we're going to switch over, and I'm going to do some of these examples for you right here. So zoom in, and here we go. Number one, right here, all they're asking us to do is add or subtract these. So first thing we're looking for is same number underneath the radical sign, which yes, we do, and the same index, and these both have 2. So when that's the case, we can go ahead and combine them. Therefore, we can take 3 and 2, and we're going to subtract those, and it's going to give me 1. I don't really need to write the 1. I can write the 1 on the outside and say 1 root 5x, or you can just write root 5x. That should be pretty simple. Okay, going on to the next one. Same thing, we're looking for the same number underneath the radical, which is 7, the same index, which is 3, and if that's the case, then I can take the numbers on the outside and I can combine those together, and that's going to give me 10x, and everything else stays the same, which is the third root of 7. Pretty easy, I know. It's going to get harder, but not too much harder. I think you're going to get this, no problem at all. Combining these ones right here, we're looking same number underneath the radical, 7xy. That's good, or same expression. And the same index. In this case, they don't have the same index, therefore, we can't do anything. So we can't combine them. So this actually is my simplified answer because I can't combine those. Okay. You might have something that comes up like this, which is to add or subtract these. And we might be saying to ourselves immediately, well, the same index, 3 through 3, that's good. Clearly the same radicand is not the case, but they're going to try and trick you because we can go ahead and simplify all of this. Okay, so take a minute, pause this, simplify each one of these and see if we can combine them together. Okay, go ahead and do that right now. Okay, here's what we should have got. This, as a simplified version, should have been cube root. This is going to be 5 times 5 times 5 times 2, which means here's my chunk of 3 because I'm looking for 3s. Okay, 1 gets out. All the other ones are gone, so that one gets out, and I'm left with a 2. So that simplifies to that right there. 5 cube root of 2. This one over here is going to simplify to give me 3 times 3 times 3 times 2. There's my groups of 3. 1 gets out, the other ones are gone, and I'm going to have 3. That should be a 3, excuse me. 3 cube root of 2. And this one right here is going to be the cube root of 2 times 2 times 2 times 2. And therefore, there's my group of 3. 1 gets out. And this is a minus, don't forget that. And it's going to be 2 cube root 2. And now you can see, after simplifying it, it is something where we have the same number underneath the radical and the same index, and therefore I can go ahead and put them together. I have 5 here, I have 3 here, that's going to give me 8 cube root 2, and I take away 2, and all of this is going to combine to give me 6 cube root of 2. Pretty easy. Moving on. I think these ones are actually not so bad either. Okay, they're not clunky and messy. All we're going to do is we're going to multiply these ones together. So when we multiply these ones together, you just have to remember our FOIL acronym. That's why I have the big FOIL walls in the classroom. Okay, because of foiling. So we're just going to go first, outer, inner, last. We're going to combine them all together and see what happens. Okay, first thing is going to go right there, and that's going to give me 20. And then I'm going to go 4 times this right here, and then just go 4 times the 4. It's going to give me 16. And it's going to be 16 root 2. Multiply these ones together right here, and I'm going to get 10 root 2. And then these last ones right here, that's going to give me 8. And then you can combine what's underneath the radical, and that's going to be 2 times 2, which is, it's going to be 8 root 4. I'll write that here, knowing that we're going to simplify that 8 root 4. Okay, so this right here, we can clearly see these are like radicals because I've got a 2 underneath and I've got the same index, so I can combine those, and those two are going to give me 26 root 2. This one over here and this one over here, you don't think you can combine. However, the square root of 4 is 2. So this is 8 times 2, which is 16. And the number 16 can combine with 20, and that's going to give me 36. So I'm going to have 36 plus 26 root 2. Those are not like radicals. So I can't combine those. I can't combine the 36 and the 26 because this is not a 36 root 2. It has to be a 36 root 2 in order to combine. Okay, so that's just foiling, multiplying. We should be okay there. They're going to throw this word at you today, and it's called conjugates. And basically what a conjugate means is that we have the same terms, but the sign on the second term is going to be the opposite. So one's going to be minus square root of 7 plus square root of 7, and they want you to see the pattern that develops with this. So we're going to go ahead and once again just FOIL. This is going to be 25, and then multiply that together, and that's going to be 5 root 7. Multiply that together, and that's going to give me negative 5 root 7. And then that right there, which is going to give me negative square root of 49. Okay, we can see if I have 5 root 7, and minus 5 root 7, those are similar or like radicals, and they just cancel each other off. Okay, because if I have 5 and I take away 5, I'm left with 0. This is going to be 25 minus the square root of 49, which is 7. So this is 25 minus 7 to get my final answer here. All of this simplifies to give me 18, which is kind of cool that we take all of this and I get just one solid number here. You're going to have to remember this because we're going to use this on problems like this. When they have you rationalize the denominator, and the denominator is an expression like this, if you remember to rationalize the denominator, typically what we would do is we want to get the square roots out of the denominator. So we would multiply the denominator by itself. In a lot of cases, when we had cube roots, we did a little bit different. But in this problem, if I want to get rid of this, if I multiply square root of 3 minus square root of 5 times itself, I'm not going to get just a solid number. But what we just found out is that if I multiply it by its conjugate, it's going to go ahead and give me just one solid number on the bottom, which is what we're looking for in our denominator. So what we're going to do is we're going to multiply this by its conjugate, which is square root of 3 plus square root of 5. And this up on the top, square root of 3 plus square root of 5. Now you're going to eventually develop a pattern. I'm going to go ahead and I'm going to multiply this out. Okay, so we're going to go like this and like this, and we're going to do our foiling. So square root of 3 times the square root of 3 is the square root of 9, which is just going to be on my denominator. It's just going to be 3. 3 times, or square root of 3 times 15, or times 5 is going to give me square root of 15. Negative square root of 5 times square root of 3 is going to give me negative root 15. And then this is going to give me negative square root of 5 and square root of 5 is square root of 25, which is just 5. Okay, that's all going to be on the bottom. Okay, and on the top, this is going to be 2 root 7 times square root of 3 plus root 5. Okay, we can go ahead and simplify all of this. And there are some tricks. I've seen people do this several different ways. I'll show you my way, and I'll tell you some of the other ways. Okay, square root of 15 minus square root of 15, those cancel each other off. And what's left on the bottom is 3 minus 5. All of that simplifies to give me a negative 2. And on the top, we can go ahead and distributive property all of this. So the 2 square root of 7 is going to be multiplied by square root of 3, and it's going to give me 2 root 21 plus, and 2 root 7 times root 5 is going to give me 2 root 35. And it's easy to think that we are actually done here, and in this case we are not, because we can cross stuff off on the bottom if we want. So in this case, okay, a lot of people would have recognized that let's just multiply the square root of 7 times the square root of 3, and that's going to give me the square root of 21, and the square root of 7 times square root of 5, which is square root of 35, and they would have left the 2 on the outside because they knew that the 2 was going to cancel off, right? I can do the same thing up here, and I can say, well, this divided by negative 2 and this term divided by negative 2, and I can cross these off. If I do it up here, 2 divided by negative 2 is going to give me negative 1 root 21. Okay, you could put the 1 there if you want to. And same thing here, that's going to give me a negative 1 on the outside, so it's just going to be minus root 35. Okay, you could do it like that, and that is my answer here. The other way you could have done it here is to simplify this and just go, these two cross off. And what I'm going to be left with on the top actually is 2 divided by negative 2 is going to give me negative 1. So it would leave me with a negative 1 on the outside. And then I can distribute this to both of those. And you're going to end up with negative 1 root 21 and negative 1 root 35. And it would be written like that. Okay, that's how you're going to rationalize the denominator. The big key here is to use our conjugate in order to rationalize the denominator. And then when you get done with it, just make sure that you have simplified everything, because you're going to want to do that. All right. Hopefully that helps. And we're done. I think you're going to do just fine with this. All right, what's going on, people? Here's what we're talking about today. We are talking about, Eli just walked in. It's gonna ruin my day. You want to be in the video for yourself tomorrow? Yeah. Did you hear that? Straight from his mouth. He said he does not want to talk to any of you, okay? Except for maybe you, Jacob, or Guyver, or... No. No, oh, he said no. Oh, wow. Hey, I'm just gonna wipe my hands of this whole situation. All right, and now Carson's coming in. This is what I do. What's happening? Oh my gosh.
There's a video.
This is Eli's class. What would you like to say to Eli's class?
What's up?
That's it?
You got this. Looks like some tough stuff.
All right, hey, we're gonna get started here, and we're gonna find the volume. You guys don't make any noise. The volume of composite figures. That just means the volume of two or more figures. So we're gonna take a look at this one right here, and we've got this box right there, and then we're gonna find the volume of that box right there. And lastly, we're going to find the volume of this purple box right there. And once we get all of those, we're going to add them up. It looks like these two, the red and the blue, are going to be the exact same. So that's a rectangular prism. So, oh my goodness, look at that. I just totally messed that up. Rectangular prism. All right. And it's the area of the base times the height. You should know by now that it's just the length times width times height. So we're going to go 3 times 3 times 4. That should be super easy. That's going to be 9 times 4 is 36. And that is feet cubed. And remember, the blue one is also going to be the same. So that we're going to say that's 36 cubic feet. And then we've got this purple one here. And this purple one is also a rectangular prism. Oops. That should be purple. And that is going to be that's a height of 1, a width of 1, and a length right here of 2. So this is 1 times 1 times 2. 1 times 1 times 2. Now, although that is, somebody shut the fridge.
Sorry.
Sweet mother of pearl. Eli's sitting there eating ice cream out of the container. 1 times 1 times 2, that looks like, hold on, that looks like 2 cubic feet. And so all we have to do is we got to add these guys up. There's that one, there's this one, and this one. And I've got 72 and 2, that looks like a final answer of 74 cubic feet. I'll add it up. All right, here's the next one. This one is only 2 shapes. It is going to be this rectangular prism right there. And then what we've got is we've got the triangular prism that's going to be here on the side right there. So we've got 2 different shapes. All we have to do is find the volume of each one of those shapes, and we should be good to go. I will let you use a calculator for this one. So we're going to find the volume of the rectangular prism first, and that is just going to be length times width times height. So we've got length of 13 times 30 times 13. So we're going to go 13 times 13 times 30. And I'm going to use my calculator on this one. I know 13 times 13 is going to be 169. And we now have to go 169 times 169 times 30, and that's going to be an answer of, oh, is that right? 169 times 30. That seemed like a lot, yeah. It's going to be 5,070. So we've got 5,070, and this is going to be cubic inches. So there's that one. And then we've got the other shape, which is going to be a triangular prism. So this one's going to be a little bit more difficult. I'm going to put myself over here, and we're going to go, this volume is going to be the area of the base. Now the base is going to be, okay, a triangle right here. So we've got this triangle right there. Okay, and I have to find the area of that triangle. So that's going to be 9 times 13. We have to divide that by 2. So we're going to go 1/2. 13 times 9. And that's going to be the area of the base. And then what we have to do is we have to multiply that by the height. And the height of this triangular prism is the distance between this triangle here and this triangle here on the back side. And that distance right here is going to be 30. So I have to multiply this by 30. Okay, so we're going to go ahead and do that. I'm going to multiply 13 times 9 times 30, and then divide it all by 2 at the very end. So we're going to go 13 times 9, which is going to give me 117. I'm going to times that by 30, and that's going to give me 3510, and then I'm going to divide that by 2, and that's going to give me 1755. So I've got the volume of this one is going to be 1755, and that is also inches cubed. And the last thing I have to do is just add them all up, and that's how you find the total composite volume of this. And so we've got 1755, and I'm going to add 5,070 to that, and I'm going to get a total answer here, a total composite volume of 6825 inches cubed. So if you know how to find volume, you can find composite volume. It's just the same thing. You just have multiple ones that you have to put together now to find the total volume. Okay, hopefully that helps, and I will see you guys later.